I'm going to show you a couple of examples of the limit comparison test, which is going to look a lot like the comparison test, but also have a couple differences. So if you take a look at that top series, notice that I've written out a couple of terms here for that series, but notice that I have a 1 in the numerator instead of a 5. And that's because you can factor a constant out of a sum. And so I could factor the 5 out, and I could basically leave that in front and rewrite that as 1 over n cubed minus 2. If you think about it, if I have a convergent series that adds up to a sum, 5 times some sum is still going to add up to a sum. If I have something that adds up to infinity, which diverges, 5 times infinity is still going to be infinity, and it's still going to diverge. So I'm going to do a comparison here to 1 over n cubed, okay? And I'm going to write out a couple of terms of that. 1 over n cubed, that's going to give me an eighth, and that's going to give me a 27th, and it's going to give me a 64th. And you'll notice here that I have a problem. 1 over n cubed is a p-series that's convergent. We have a p-value of 3, and that's greater than 1, so it's going to be convergent. The problem is, if I'm going to compare to the series, I need a series that has terms that are smaller than the terms of the convergent series. And if you take a look here, 1/6 is a little bit bigger than 1/8. 1/25 is a little bit bigger than 1/27. 1/62 is a little bit bigger than 1/64. So although it looks a lot like a convergent p-series, my terms are a little bit bigger, and just because I have a series that converges, if I have another series with terms that are greater than or equal, they won't necessarily converge as well. So here's where the limit comparison test comes into play, and I have this over here. It says that I can, if I have two series that I think do the same thing, I can compare the ratio of the two series, okay? And it doesn't really matter which you put on top and which you put on the bottom. So I could do 1 over n cubed minus 2, and I could divide that by 1 over n cubed, okay? Now remember, when you divide by a fraction, that's the same thing as multiplying by the reciprocal, okay? So this is exactly the same thing as dividing 1 over n cubed minus 2 as multiplying it by n cubed over 1. So I'm going to rewrite that as multiplying by the reciprocal. That'll make things a little bit neater here. And remember that you're actually taking the limit of this, strangely enough, as n approaches infinity, okay? And so what I'm going to be looking at here is n cubed over n cubed minus 2 as n approaches infinity. Well, if you think about that, I've got a cubic in both the numerator and the denominator, and that's totally going to overpower that negative 2. So over time, that limit is going to approach 1. Okay. In other words, as I go very, very far out, that ratio between those two different series is going to get closer and closer and closer. It's basically going to become the same thing. And here's what the limit comparison test says. If you get any constant, okay, doesn't have to be 1, it can be 2, it can be a half, it can be a fifth. But if you get a constant, those two series will behave the same way. And what that's really saying, like, for example, if I had 1/2, you're basically saying, if I had 1/2 instead of 1, you're basically saying the denominator series is behaving the same way as you go farther out as twice the numerator series. Okay, if I had 4 as a constant, that's 4 over 1. That's just saying the numerator is behaving the same way as the denominator as you go really far out, except it's 4 times as big. But the point is, in the end, one is basically just behaving like a multiple of the other, which means their convergence should be the same. Either they both converge or they both diverge, all right? So in this particular case, 1 over n cubed converges. That means that our original series, running out of space here, but our original series is also going to be convergent by the limit comparison test. But again, we have to use that instead of the regular comparison test because we think it's convergent, but the terms are bigger than the terms of the other convergent series. So we can't just use the regular comparison test. Okay? In another video, I'll look at yet another example.